We're still doing index laws, so we're still learning how to simplify expressions that have exponents or indices in them. But now we've got a few more. We've got this rule that I quite like because it's pretty simple, really. This says a to the power of 0 is 1, as long as a is not actually 0 itself. So anything raised to the power of 0 is just 1. What's 5 to the power of 0? It's 1. What's 100 to the power of 0? 1. What's 3 to the power of 0? It's 1. Good. This one here, I've got 5 times x to the power of 0. Now you might be thinking, oh yeah, the whole thing is just 1. But what is being raised to the power of 0 here? It's just the thing immediately before it. Exponents only apply to the thing just before it. I would think of this as 5 times x to the power of 0. There's an invisible times sign between the 5 and the x. If we think back to BEDMAS, we have to do this exponent before we even think about that multiplying. So there's an invisible times sign there, which I've written in, and now we can actually figure out, well, this x to the power of 0 is 1. So the 5 stays the same, it goes down, the multiplier copy down, but I replace x to the power of 0 with 1 because anything to the power of 0 is 1, unless that something is 0. So now 5 times 1 gives 5. That's not so bad. Let's try, now we've got numbers and letters, and they're all mixed up. If you're multiplying, numbers and letters together, I like to separate it into the number part and the letter part. So here, we've got 2 times x cubed. In between a digit and a letter, there's an invisible times sign that you can imagine right here. That's why I've drawn it there. Then I copy that times sign down and copy the 3 down. There's an invisible times sign between the 3 and the x, between a digit and a letter, so that can go down there as well. And you can see what I mean about separating into the number part. I've got the number 2 and the number 3, so let's put them first. And now we've got the letter part, x cubed and x squared. So let's put them together. Now it's a lot easier to figure out, because 2 times 3, we know what that is. That's just 6. And x cubed times x squared, we add these exponents to get x to the power of 5. To simplify it even further, we can turn this times sign into an invisible times sign. And that is fully simplified. To be fully simplified, we get rid of any times signs if we can, because someone looking at this will know that there's a times sign right there. All right, last one for the page, and then we're done. That'll be nice. One trick, if you have brackets, expand them first, and then split into the number part and the letter parts. So we're worrying about the brackets first. This whole thing has been squared. So the a is getting squared and the b squared is getting squared. Each of these two things, the a and the b squared, need to have a squared on them. So that's what we're going to do here. The a will get a squared on it and the b squared will get a squared on it. Do you notice that I've put brackets around the b squared? Because otherwise it would look like b22. If you have a power on the outside of the brackets, each of these things on the inside will get that power. The a gets the squared and the b squared gets the squared. Okay, so we still have brackets though, so I guess we'd better figure this out. This is that rule that if you've got an exponent on the outside of the bracket and another one on the inside of the bracket, then you can multiply them together. So this is b to the power of 2 times 2, which is 4. So all I've done here, I've color-coded it by the letter and number, but I've just turned that b2 times 2 is 4. So this is b to the power of 4. And now we can do our trick. We can put all the number parts together, all of the a parts together, and all of the b parts together. And they'll be with their friends, and that would be really nice. First, let's write the number parts. For the number parts, I've got the 2 times 3. And then for the a, on the top, I've got a squared, and on the bottom, I've got a squared. Notice that these things are being multiplied. There are invisible multiply signs there and there. And finally, the b terms, I've got a b cubed on the top and a b to the power of 4 on the bottom. Okay. There's nothing underneath here. There were no numbers on the number parts on the bottom, just on the top. You can imagine there being a 1 there. Really, I should probably write that there's a 1 there. If there's nothing there, it's just a 1. On the top now, I've got 2 times 3. Well, 2 times 3 is 6. There's nothing on the bottom still. I've got a squared divided by a squared, which will cancel out. They're exactly the same thing. So if you have the same thing on the top and the bottom, you can just cross them both off, which I'll do. Chink, chink. And they'll cancel out. The answer will just be 1. And finally, I've got b cubed divided by b to the power of 4. This is a fraction with an exponent on the top and the bottom. They have the same base, so it will be b to the power of 3 take 4. 3 take 4 is minus 1. Now this is okay, but it's not really fully simplified. 6 times 1 is just 6. And then I don't need to write the extra time signs between the 6 and the b, because someone looking at it will know that there's a time sign there. How much simpler is this than this up here? This was a real mess, but this is so much shorter. So it's really powerful to be able to simplify index laws. Now, technically speaking, because there was nothing at the bottom, it's maybe a little bit unconventionally nothing at the bottom. So I really probably should have had a 1 at the bottom. But in my head, I imagine a 1 as being nothing left on the bottom. Okay, so which ones to try now? Questions 4 and 5 from 2B.1 would be a great one to tackle. All right, good luck and good work getting stronger at maths. Bye.